Hi everyone. In this video, we are going to build a complete retrieval augmented generation or RAG pipeline using Microsoft Fabric, Azure OpenAI, and Azure AI Search. So, what exactly is RAG? RAG is a pattern where instead of relying only on a language model training data, we enhance its response by retrieving relevant information from our own knowledge base. This means the model can give more accurate, up to date, and domain specific answers. In this notebook, we will walk through the full pipeline from loading data to generating embeddings to retrieving results and finally generating answers. So let me make it a big so that you can understand what we'll be doing here. I hope this much is fine. So first step basically we need to install Synapse ML. What is Synapse ML? Synapse ML is an open source library that integrates Azure AI services with Apache Spark. We'll use it for three main things: splitting text into chunks, generating embedding using Azure OpenAI, and generating responses using GPT model. If you are running this for first time, you may need to restart session after installation. So let me do this first step. I have already done this before, so I'm doing it again. So we don't need to. I don't need to restart it. Once that step will complete, let's. So this step basically we are installing Synapse ML using pip. This step ensure we have access to all the required transformers like page splitter, embedding, generator, and chat completion API. Let's wait for this one to complete. This one is completed. Let's go to the next step. We load our knowledge base. In this example, we are using diabetes treatment FAQ datasets stored in the Fabric Lakehouse. The dataset contains two main columns: topic, which represents the category, and description, which contains the actual content. The dataset will act as the source of the dataset will act as a source of truth for our RAG system. So let me show you this our data lake. We have already upload our dataset here, and while we are talking about this Azure AI services, we'll also go through that Azure OpenAI. So Azure OpenAI. Here we have created one service Azure, and inside it we can see our endpoints and key. Let's wait for some time. Okay. So here, if I'll go to security or resource management, key and endpoints. So we have these, we need this and this while we are calling the our GPT model. So in this exercise, we are using GPT-O 4.0 model. Let me also show you. So for that, basically, we have to go to Azure Foundry. While create that, if you have seen it, we have this Open Foundry, Explore Foundry portal. So where it will we have created our GPT model deployed. GPT-4 model deployed. We have the key here and the same endpoints, and version number, API version number is also here. And this is the code which we have used in the previous our previous labs as well, in one of the labs as well. And we can also go for the embedding model. So embedding model, I have a different endpoint, and embedding model we are using text ADA002. Text embedding ADA002 model is there. Yeah, and another thing is we have AI search. So AI search, go to AI search, and I have already created a one AI search here. Here also we need keys. So these are the keys we need it. While we'll call this an endpoints an index name. So index name can be anything. While we'll go through the complete lab, we will explain. So here in this cell, here we are loading. Let me start first. Here we are loading the CSV file into Spark data frame. We enable the header option so Spark correctly read columns names. Once loaded, we display the data frames to verify the data. So we can see that data is there for each column and questions are there in FAQs, and each column we can see the data here. So here what we are talking about the Azure services, we have already gone through some of the Azure services. However, so now basically we are configuring the Azure services. We need credentials for Azure OpenAI, which we will handle embedding and chat completion. The Azure AI Search, which will store the retrieve vector data. These configurations are essential for connecting our pipeline to external AI services. So these are the keys which we have to will use it for our lab. However, we define these API keys and service names. These includes Azure OpenAI and resource name, Azure AI service name, and the index name. Make sure to keep these values secure and never expose them publicly. So we have in Azure in Fabric we can store it in the somewhere in the secrets. So I haven't explored that much now, but you can explore it. So let's come to the next cell. Now we move to an important step: chunking the text. Language model have limits on how much text they can process at once. So instead of sending large document, we split them into smaller chunks. We use the page splitter to limit chunk size, remove very small fragments, and prepare the data for embedding. This improves both performance and accuracy. So this is the code, and this maximum page length, as we can see, you can read it as well. We are using 4000, and set minimum page length is 30, and we are just doing this code to just split the pages. Let me execute it. So here we basically configure the page splitter. The input column, which is in description, the maximum chunk size, which we have discussed, 4000, minimum is 30, and the output column. This will generate an array of text chunk for each row. So next step, you can see that we have the chunks available, and if you'll go, you can see the chunks are there. It's basically the data is small, so you can see that it is only 1 0 0 is always 0 0. Yeah. So now we are coming to the exploded chunks into individual rows. After splitting, each row contain multiple chunks stored as an array. But for embedding and indexing, we need one chunk per row. So we flatten the array using pause explode. This gives us the chunk index and the actual chunk next text. We then create a unique ID for each chunk. So here is the code for the creating the exploded chunks. Here is the exploded chunk. So for each row contains a single chunk and we assign it unique IDs. Let me run it so that we can explain. We can see that. So we have the each a unique ID. Unique ID 0. This one's unique ID for each row. It is there. Let's go to the next step. Generate embeddings basically. Now that we have a clean text chunk, the next step is to convert them into embedding. Embeddings are numerically vectors representation of text. They all allows us to measure similarity between pieces of content. This is the core semantic search. Rather than matching keywords, we match meaning. So in this cell, we use Azure OpenAI to generate embedding. We specify the input column, and this basically. Let me run it again, this one first, and then. So in this one, we input the input column containing the chunk text, the embedding model, and the output where vectors uh, will be stored. Each chunk is now transformed into high dimensional vector that capture the semantics meanings. Let me run it as well. Creating a vector search. So preparing the data basically. Preparing data for indexing here. Before sending data to Azure AI service, we prepare. Let me go back again. Before sending the data to the Azure AI service, we prepare the structure. Each record should include a unique ID, the original text chunks, and the embedding vector. This ensures the search index can efficiently store and retrieve results. In this code, here we select only required columns for indexing. We keep the unique ID, unique chunk ID, the chunk itself, and the embedding vector. So you can see that we have a JSON object which have the ID, unique ID, unique chunk ID, and then content itself and the vector embedding vector in this. So basically, since I have already executed before, so it is showing that me update. Otherwise, it will show us as a index created. This index, if you'll go and see it here in documented search management indexes. So you can find the indexes here in the search management on the Azure portal. That index is already there. So it's already, you can see that count of the document count and everything is available here. Let me go back to my notebook. So that first step, basically it's only index is updated because index was already there. Otherwise, first time it's only create the index and then we have to update the index, upload the chunks to the index. So upload to Azure AI Search, basically Azure AI service. Now we push our data into AI Search. This is where vector search happen. AI Azure AI Search stores the embedding and the corresponding text. Later, when a user asks a question, this will search the this index to find the most relevant chunks. So in this code, basically Let me start this code. We configure this service name. Basically, in this step, we write a data frame to Azure AI Service. We configure the service name, the index name, and the authentication details. Once this runs, our knowledge base becomes searchable using vector similarity. Let it complete. This one also completed. Success. Now we move the query side of the pipeline. This, this is where our users ask the questions. We'll take the query, convert into embedding, convert it into embedding, and then search the similar content in our index. Here we basically define a sample query. For example, a question related to a diabetes treatment. This query will go through an embedding and process our data set. Let me execute this step. So this step basically to search the most relevant chunk, and we'll have the basically we have to give the stored queries and the queries, generate the embedding and the query both. Perform vector search. Basically, it will be search the perform vector search from the Azure service, Azure AI Search. Build the perform. Basically, this one is basically a performing a vector search. Now comes the retrieval steps. We send the query embedding to Azure AI Search and ask the most similar result. This is typically done using k nearest neighbors, where we retrieve the top matching chunks. Here, here we perform the actual vector search. We configure the number of top results to retrieve and the search parameter. The output will be most relevant chunks from our data set. So this is the function which we will create. So this step basically where we are just preparing context. This step, once our retrieve relevant chunks, we combine them into a single context. This context will be passed to the language model. The idea is simple: retrieve, find the right information, generation turn into natural answer. We concentrate the retrieved text chunk. This create a structural context that will guide the model response. Let me execute this one. So please, once you will get time, you will just go through is all these steps, and it's basically going in our Azure AI services and getting the response using the Chat GPTO model. So now the last part will come up. Generate final answer. Basically, now we reach to the final steps. We send both the user query and the retrieve context to the language model to get response. This is what make RAG powerful. The answer is grounded to real data. We provide the system prompt, the user query, and the context retrieve context. The model then generates the response based on the based on both its training and the retrieved information. The output that the output that the end user would see, because we need we use RAG, the response more accurate, more relevant, more and the grounded our data set. So how to build a complete RAG augmented generation pipeline using Microsoft Fabric and Azure OpenAI AI Search. We covered data ingestion, chunking and embedding, vector search, and response generation. If you found this helpful, don't forget to like, share, and subscribe. Thanks for watching, and I'll see you in the next video. Thank you.